I'm doing fairly well.
Good, man.
Yeah. Um, see, I had a lot of notes here in the side. I'm not sure where to even start with it. Um,
Well, first off, how do you feel that the discussion went? Did you enjoy it? Did you feel like we brought up some topics? Did we cover a few things that like how do you feel it went?
I think it sounded a lot like the conversation you and I had. So I don't know really if there's anything else to say, but um, yeah, I don't know. Let's see. One of the things that I think you seem to miss about ERVs is that ERVs, viruses in general, necessarily must have a mechanism by which they can induce transcription, right? So wherever the ERV is, you're gonna get transcription, and
Are you talking about spurious transcription? You're going to get some type of function based because you remember we were talking about spurious transcription.
yeah. Well,
Are
but
you
but
saying this applies to the RVs as well?
what I'm talking about is that the ERV, in order to produce the viral proteins, it's got to transcribe them, right? First, it uses reverse transcriptase to get its genetic material into the genome, right? And then it has to transcribe its genome back out so that it can be translated. So that means it has to have a bit in there that will induce transcription. Now, if you lose the viral genes, but you keep the promoter region, you just get transcription of whatever is left.
Okay, so where I'm coming from is I'm saying, and obviously I'll allow you to respond to this, but I'm just saying viruses, at least it's not observed, they do not randomly insert tens of thousands of, say, these endogenous retroviruses, which just happen to be in exactly the right location and having exactly the right sequence to perform some valuable functions. So I'm saying no ERV should have function because the fact that there's increasing evidence that they have important functions in the placenta and in the embryo, and the fact that they aid transcription in a fifth of the genome, I would say this is strong evidence that ERVs were possibly not the product of retroviruses, or it could be a weakness in the system. But most importantly, and you're going to know about this because you're a scientist, there are cell processes designed to weed out harmful or viral infected genes known as apoptosis, right? So why, after millions of years, do we still have so many viral infected ERVs, ERV cells? Because shouldn't apoptosis have ridden them long ago? But apparently it hasn't done anything at all. Go ahead.
Well, that's not how apoptosis works. But anyway, so you previously defined functional as basically transcribed, right? But any ERV must cause transcription.
Transcription, but also very important placental roles and
Well, no,
placental.
but you didn't define functional as being transcription plus do something. You defined it as just transcription.
Do these ERVs do something?
Some of them do, but that's not how you define functional. You define functional as just transcribed. If it's transcribed at all, according to you, according to what you've said multiple times, including more than once in this
I'm saying
hangout, if it's transcribed at all, it's functional, according
I'm
to
saying
you.
transcribe suggests function. We haven't done these gene
Right.
knockout
Well,
tests
actually, it
to
doesn't suggest function.
conclude. But you just said that these ERVs have placental functions, embryological functions. That's consistent with my model. You can
Yeah,
have any type of
well, no,
interpretation of this all you want. It's
it's
consistent with
not
design.
consistent with your
It is
model.
consistent with design.
But so, firstly, the fact that some ERVs have some functions which may or may not be necessary, depending on context, does not mean that all ERVs are functional, obviously.
Okay, well,
Additionally,
I think it's important for the audience first because I believe we speak, and by speak I mean understand, maybe 1 to 5% of the DNA language. How much do you believe we understand or speak of the DNA language? Go ahead.
I still honestly don't know what you mean by the DNA language.
Okay, so for one, we've already overturned ERV from junk to function. Okay, so I think that's consistent with us. Secondly, my question is once again, I'm going to state how much of our DNA, deoxyribonucleic acid, how much of our information systems do we truly understand? Like,
That
I
was
don't
a
know another way to ask it.
that was a remarkable restatement of the thing I asked you. You just resaid the thing I asked
How
you
come you
to
don't
explain
understand such a
to
simple
explain it.
question? If
Because
we've
it's
never
like
performed these gene knockout tests on humans and other mammals
because
to
it's like
conclude what type of functions they
you
have,
said
why are you so
how much how
unwilling to
much
think we understand it all?
how much of the Squanch language do you understand? What the hell are you talking about?
Exactly. If I look at a
I know
Russian
what
input,
DNA is. I know what
I'm not gonna understand any of it. But it doesn't mean that if I look at something that I think is junk or non-functional, I'm not gonna conclude, oh wow, that really is junk, or an evolutionary leftover, or an ancient repetitive element. I'm ignorant of the language, and I'm saying you're ignorant of the DNA language. That's all I'm saying.
Oh, so yeah, we can tell whether or not things are functional.
Oh yeah, have you done these gene knockout tests on humans and on other mammal species, and how much
Yes,
testing have they
actually,
done
I
on
actually
the
funnily
embryological
enough, yes, I
development?
have. But there are other ways beyond knockout experiments to test for functionality, and knockout experiments aren't even really the best way to do it necessarily. So,
I would disagree with that, but go ahead.
well, I'm really impressed that you would disagree with it, but I don't know what your point is because like
Okay, about the say embryonic or placental development. Okay, I would say it's a mystery at this point. The fact we don't know the manufacturing tools of say embryonic development does strongly hint that we don't understand most of the DNA language. And the
right,
fact
but
that we only speak 1 to 5% or understand 1 to 5% of the DNA language, and ENCODE has revealed that 80% is transcribed. And all
it
I'm saying is that suggests function. Okay, so
right.
that's our prediction in
So
this.
so when you say that it's found that 80% is transcribed, you understand that all that means is that they got at least one read in one sample, right?
One read in one sample. Yeah, obviously I understand that that this isn't. How much did ENCODE actually test?
Well, they,
Uh,
they, they tested a lot, but the question is, if you only find one read in one sample, when you would expect for something that's actually doing something that's being transcribed beyond a spurious level to find millions of reads across the samples. Do you think that one read in one sample is impressive?
I would say that uh, doesn't definitively give us a function, but it does suggest possible function. So I want to ask you, pseudogenes, are they part of this 80% of that section that ENCODE tested? Would pseudogenes be part of that? That was shown to have this spurious transcription or transcription?
I imagine they tested a lot of different things. It's
Okay.
been it's been
Okay.
about
Well,
three it's been about 3 years since I read through their work in detail. So
okay, well, I'll give you the answer. Pseudogenes were definitely part of the 80%, and we know that some pseudogenes are actually no longer pseudo. That means that 80% function is beginning to look more and more reliable as we are predicting. And the fact that we know so little about the embryological
the
developmental phase is strong evidence
the real
uh,
problem
for
is
creation. Go
that
ahead.
we know that the absolute maximum amount of the genome that could be functional is 25%
Oh,
at
you know that for a
absolute
fact?
most. Yes.
So you speak 1 to 5% of the DNA language. You know nothing about the construction tools that are taking part in
No,
that developmental
we
phase.
actually
You know
do know a
25% is the
lot
max.
about development. I don't know where you're getting that we don't know anything about development. We know a lot about development.
But the thing is, a lot of this development, a lot of these construction tools being utilized during that phase are in that non-protein coding region that we, or evolutionists might say, are junk.
I can't imagine what your point could possibly be with that.
The whole point is the trajectory is pointing towards, I understand you disagree, it's pointing towards genome-wide functionality, but based on the fall, based on our model of degradation and genetic entropy, which I understand you don't agree with, that's fine. We will expect some junk, some broken genes, some pseudo genes, but not, say, as many as evolutionists would predict. So I feel the empirical evidence is more consistent with biblical creation. Go ahead.
Yeah, well, but the problem is that again, there have been studies done, fairly substantial ones that have demonstrated the amount of the genome that could possibly be functional, and this is on a very broad, both theoretical and experimental basis. So if you're wanting to say that it's, the majority of the genome is functional, you're already wrong. You just cannot be right about that because it's already been demonstrated to be false. Now I know you're not up on the literature,
Oh
but
no,
actually,
I'm up on
that was
I'm up on the
demonstrated like
literature.
40 years ago.
Evolution predicted junk since the 70s. Would you agree with that? Since the 70s, they have predicted junk. They didn't predict.
Yes,
The thing I'm
1972.
understanding is they didn't predict that ENCODE would sequence and look at that the analysis there and conclude that 80% is transcripted. So now you have to use your rescue device based on that evolutionary bias and assumption and say, oh, well, it's spurious transcription. Oh, well, it's this, it's that. Common ancestry markers in DNA has a junk DNA assumption to work. And that's a fact. Without junk, you're genetically dead. And
are you under the impression that spurious transcription is a concept that came about after ENCODE?
No, I'm saying that they didn't predict that 80% of that would be transcripted. There's
Actually, the point of spurious transcription is that it predicts that the majority of the genome will be transcribed at a spurious level.
Are you familiar with Francis Collins, who's I think he headed either the Human Genome Project or, I mean, he's pretty
Yes,
popular.
I know who he is.
Okay, and this definitely isn't a quote mine, but even he said, and I think this was after his prominent work with Language of God, and a lot of evolutionists look to him actually for evidence and information, but he said in terms of junk DNA, we don't use that term anymore because I think it was pretty much a case of hubris to imagine that we could dispense with any part of the genome as if we knew enough to say it wasn't functional. Most of the genome that we used to think was there for spacer turns out to be doing stuff. So this stuff that, according to Francis Collins, that it's doing, is this stuff functional by your definition or functional by, say, the creationist interpretation of functional?
Yeah, so I'm not sure if you realize that you're quoting an ID proponent talking about
Well,
junk
Francis Collins
DNA.
is not he's not an ID proponent like Stephen Mayer, or he's all for universal common ancestry, pawns come to people evolution. I mean,
But
sure, he
he
believes
is
God's
nonetheless an ID proponent. He doesn't support the same type of intelligent design, but he does still support a form of intelligent design.
well, yeah, God sparked the Big Bang and God sparked the initial life, but
And
those are just things.
controlled the development.
No, I think he just believes that God, snapped his finger and the process began, but it was still all non-random.
So you heard, so you heard it here, folks. God is Q from the Q continuum. Snap.
No,
Sorry, I had to make another joke.
I'm saying I would say theistic evolutionists, holding on to microbes to man evolution. I think it's pretty obvious that they're compromising because I mean, for one, why would God use that process of death? And secondly, it really is just God of the gaps. Hey, evolution happened, but God snapped his fingers, and here's life, and God snapped his fingers, and here's the Big Bang. I mean, that's we don't have to get into that conversation, but I'm not saying that I agree with Francis Collins, Athena, or
Yeah, I
Midnight.
never said you. I never said you were, but but when you think about it, the creation model also seems to think that God created the universe snapping his fingers.
Well, yeah, but our model is totally different. I mean, have you listened to anything I've said
No, I just I've honestly been
pre-existing heterozygosity?
tuning you out, dude. No offense.
Oh, so that was another good one. So the heterozygosity, you realize that the absolute maximum number of variants for two people would be 4, right? You would have 4 variants.
I completely understand, alleles and allele frequency, but I'm saying that starting with heterozygous organisms, visible distinctiveness in offspring, it would be apparent right away because recombination, gene conversion would provide many new varieties of those combinations.
No, that's not how that works.
Yeah, but you're assuming that those differences weren't already built in because you're looking at those.
You could have 4 differences built in. You could have 4 different alleles for every gene with 2 people. Each of them could have 2 different alleles. So you'd have a total of 4 alleles possible. That's it.
No, because a small heterozygous population will tend towards homozygosity. So when this happens, some recessive traits will be revealed. Look at the Mendel experiment on the P proteins. It shows that speciation and new traits can happen quick based on those recessive and dominant.
Yes, but the number of possible alleles is 4.
No,
not infinite.
The amount of possible allelic variety based
Is
on those
4.
millions of differences in DNA sequences or
No,
pairs,
you can have
limitless.
Each of them can have 2 different alleles. They cannot have more than that. Only 2. Only 2.
Two
Between
alleles.
the 2 people, between the 2 people, you could have 4 alleles. That is the most.
No,
Exactly.
You don't even understand what I'm saying. 4 alleles with pre-existing differences can, by estimate,
but each allele,
80,000 pre-existing differences. Don't cut me off. That can have 80,000 pre-existing differences. Okay, those tens of million of nuclear DNA differences you see and assume are based on mutations. We're saying those were placed and encoded into the original created kinds. That plus pre-existing heterozygosity is more than enough variety and potential for speciation.
Okay, so you don't know what the word allele means.
Darwin. Your argument is debunked on the first page.
So you don't understand what allele means because an allele is the entire gene. It's a version of the gene. So if there's multiple differences in the gene, all of those differences make up one single allele. And each person can only have 2 variants.
But what I'm saying is, if you look at, say, Adam and Eve, okay, 2 people, low allele and low genetic diversity, that matches. You would look at the original created kinds, that would be high allele and high genetic diversity because you're looking at populations of heterozygotic organisms. Go ahead.
Okay. So what you're saying is...
So do you think that Dr. Nathaniel Jensen wrote an entire book, wrote all these predictions, but what you're saying just completely debunks it? I mean, you think he just completely overlooked that point? I mean, we're saying
tens of millions.
Nathaniel Jensen actually, turns out, as people have read his book, it turns out that he discarded information that was irrelevant, or not irrelevant, but was inconvenient rather to his own predictions and that what scientists have already found.
No, because when he debated Dr. Mays, he exposed him for not understanding that we are saying that these tens of millions of nuclear DNA differences, probably 90% of them, 10% of them based on mutations, designed variation.
Oh,
That
also,
combined.
Standing.
So actually, Jensen, since comeback, whenever he was confronted with actual things that his book mentioned, was show me where it is in my book. Not show
Yeah,
me the literature, but show me where it is in my book.
All right, now,
because everything that
Jensen
Dr.
knows.
Mays was bringing up was explained in his book through those tens of millions of nuclear DNA differences from the start. Go on.
Sandy, you're missing something critical here, right? Which is Noah only had 2 of each kind. 2.
Yes, but up to that point,
Up
the
to that
amount of
point, be
compressed-
damned. They didn't make it past the flood.
the amount of compressed and hidden information and hidden traits
Where was it hidden?
is limitless.
Where was it hidden in the genome?
Hidden in, well, for one, in a lot of these DNA sites that you would call junk or non-protein coding. But like I said before, 4 alleles with pre-existing differences can, by estimate, have 80,000 pre-existing differences. I don't understand
No,
why.
it can be
So
4.
it can't be hidden because if it has the mutation, if it has that particular variant, it would be constituted already by the definition of the allele. So that argument fails.
No, it doesn't fail. And actually, after the global flood and after Noah's Ark, based on that, those after effects of the flood, the radiation, that would have sparked tremendous variability, allelic variation based on, say, the radiation after the flood. It's really not an issue at all based on that pre-existing heterozygosity.
So
but we can agree to disagree. That's fine.
We can move away from how wrong you are about genetics. That's fine. Let's talk about, you were saying, I believe I heard you say that it's your impression that the rate of radioactive decay must have been sped up. Did I understand that right?
So you want to jump into actually, yeah, we can talk about that, but I want to talk about because I think a strong evidence of molecules to man evolution, if you would agree, would be the chromosome 2 fusion. Would that be something worthwhile just to get?
Oh yeah, that'll be fun.
If we're gonna rehash the same thing that me and Immutable Destiny discussed, we can do that. But wouldn't it be fun to have a variety of topics here?
Yeah, sure. Let's do chromosome 2. That'll be funny.
Okay, so if we look at chromosome 2, obviously we would, humans may have had. For one, I want to ask, when did this fusion occur? I think would be a good question. Was this in the human line, or was this in the line prior, like through our common ancestor between chimps and humans? Go ahead.
It occurred after the divergence with chimpanzees. Divergence from chimpanzees.
Okay, so technically the argument would be if humans and chimps share a common ancestor, then we should observe a fusion event. Human chromosome 2 shows evidence of a fusion event. Therefore, humans and chimps share a common ancestor, right? More or less, because human chromosome 2, say near the middle, is it like remnants of centromeric DNA?
No, it's not remnants of centromeric DNA. It's there are head-to-head arrangements of degenerate telomere repeats.
Yeah, so like telomeric DNA is only found on the ends of DNA, but on chromosome 2, you find that DNA in the middle, right?
In a head-to-head arrangement.
And is it vestigial?
Vestigial. I mean, it is what it is. What?
Like, is any part of that fusion vestigial? Like, is there any function to it?
No.
Why have we found telomere sequences in the DNA that actually prevent this fusion?
Right. So telomeres, when they're functioning properly, would prevent fusions. That is true. However, when telomeres are not functioning properly, they tend to no longer exist anymore, which allows for fusions between non-homologous regions of the chromosomes, which is most readily achieved between reasonably homologous regions, which would occur within subtelomeres where you would find degenerate repeat regions, which is exactly what we see in the middle of chromosome 2.
Okay, so before we get into anything more deep in regarding to that, based on how I explain the argument, right? Like if humans and chimps share a common ancestor, there should be a chromosome 2 fusion. There is, therefore, that's evidence, right? But wouldn't that be a logical fallacy known as affirming the consequent? Like if the grass is wet, then it must have rained, right? But the grass is wet, therefore it rained. But the thing is, the grass could be wet for a number of reasons. So what I'm saying is that the human chromosomal fusion argument, and obviously I want you to comment this, it really focuses on a fusion event that is specific to the human line and therefore provides a highly limited, I guess, form of evidence for human/ape ancestry. Because if it occurred in that human line, but you're using that as sufficient and demonstrable evidence for ape human common ancestry, isn't that just affirming the consequence? Go ahead.
That's not what anybody's doing. The argument is that without a fusion, things look really weird. There is a fusion, therefore things don't look really weird. It doesn't mean that common ancestry is confirmed. It means that a possible roadblock to a strong support of common ancestry has been removed.
Okay, but how?
It is not. It does not exist as a piece of conclusive evidence, singular evidence that demonstrates the case. Instead, what it does is it removes a problem to this thing being the case.
Okay, but how could the gene span the fusion site? Like seeing one part of it from one side to another seems a little bit unrealistic and a little bit of a stretch. Go ahead.
I assume you're talking about DDX11L2?
Sure.
So you don't know?
Yeah, that's exactly what I'm talking about.
Okay.
Like
Yeah, great.
how would you, because for one, the telomeres are functional. Wouldn't that indicate that the fusion is impossible, or did that function come about through the chromosomal 2 fusion? Like, how do you reconcile?
No, when you say the telomeres, do you mean the fusion? Are you saying the fusion is functional?
The telomeres are functional, which would make the fusion unlikely based on that function that it possesses.
I think that most people would agree that telomere fusions are indeed unlikely, but they do happen.
Here, but
we've seen a lot of them.
Do we see those fusions take place in human populations today?
Yeah, there's a guy in China, and I think a family in Sweden.
Are those passed on to?
Yep. 9 generations.
But what I'm saying is, wouldn't only a junk telomere be able to create this fusion?
But probably no telomere at all.
Like
I said,
I'm saying the fact that only a junk telomere can create this fusion, doesn't that alone debunk the fusion? And if there even was a fusion, based on what you're providing for the evidence of the fusion, sounds like a logical fallacy called affirming the consequence. So it sounds like either way, fusion or no fusion.
No. So the thing is if you knock off the telomere from one chromosome, right?
Yep.
That end of the chromosome is going to want to fuse. Now, you can't stop fusion with one telomere, right? You need one on either end, right? They work, the ends work like bumpers. If you only have it on one side, you can still get a fusion. Now, the most likely place to get a fusion is when there's some degree of homology between the regions of the chromosomes. The thing is, every single chromosome at the ends, inside of the telomere, you have subtelomeric regions. And these regions have areas of very high levels of movement within the genome, but they also have generally degenerate telomeric arrays. And those arrays are largely homologous to one another, which means you have a very good site for non-homologous fusion, because it's semi-homologous at that point. Now, what all of that means is that what you would expect to see at the fusion site is a mixture of degenerate telomeric arrays, which is what you see, along with the genes, pseudogenes, and various other sequences commonly found by the subtelomeres, which is also what you see, including, of course, a version of DDX11, which are only found by the telomeres. That's the only place you find it in the genome is by telomeres, and also in the middle of chromosome 2.
Okay, so from my understanding, this degenerate part that you're talking about, it shows function. Secondly,
it doesn't.
You just talked for a while there. That fusion thing was conceived, right? The chromosomal 2 prediction sounds like decades ago biology to me, because that fusion was predicted and conceived during the junk DNA era. Without junk DNA, the fusion really just collapses on its own. And lastly, based on what I said earlier about evolutionists, and in regards to this, all they have done is really documented direct empirical evidence. Say if this chromosomal fusion did happen, either way, I don't think it's evidence, but it happened in the human line. So it doesn't tell you when it happened and what was happening when it happened. So it sounds like presuppositions play a huge role on the interpretations of the evidence. And it also sounds like all evidence becomes evidence for evolution. For example, if chimps and humans both had 48 chromosomes, oh wow, evidence for evolution. Okay, chimps have 48, humans have 46. How do we reconcile that? Must have been some type of chromosomal fusion. Bam, evidence for evolution. Everything is evidence for bacteria to biologists, evolution. Go ahead.
Well, if there hadn't been a fusion, that would have been a fairly strong case against common descent.
Well, I'm saying there's evidence that possibly there wasn't a fusion, and I'm saying that even if there was a fusion, it doesn't tell you when it happened, what happened, and how it happened. But the thing is, based on our limited understanding of the DNA language anyways, and I've said that many times, it's premature to make these conclusions. And let's just say hypothetically there was a chromosomal 2 fusion. That means when it happened, it had to have been passed on to everybody for us to all have it, correct? I mean, is that not unlikely? And if it is likely, wouldn't that be based on a story? Like, aren't you going to have to tell me a fancy story on how that happened? Go ahead.
Can I do a screen share?
Yeah, go ahead. Screen share, and I'll present to you.
Okay, here I'm going to let you.
I'm going
to let you have the last words in regards to that. I'm going to have to head out actually in about a minute. Have the last words. I don't mind that, and you guys can continue the talk. And then we'll go from there, and we can do another one.
Hang on one sec. Before you leave, hold on. Present to everyone. There you go.
Okay, you want to see the evidence? This is the evidence.
I'll give you the last words, the last evidence. Go ahead.
This is a Centene map. On the
interesting.
In the middle, you have human
position is like interesting, even though he's got no idea what it is.
I'm explaining it. In the middle, you have the human positions. On the left, you have the equivalent positions in mouse. On the right, you have the equivalent positions in chimpanzee, color-coded by the chromosome correspondence. This right here is the only jump between human and chimpanzee
Does that
Yeah.
degeneration show any function at all?
These actually represent, each of these lines represents a fairly large chunk of DNA.
Hmm.
Now, you look at this in mouse, there is no reason to not, if there's no common ancestry, to not expect to see something just as jumbled between humans and chimpanzees as you do as between humans and mice.
So
But you
I'm
don't.
saying,
You
saying
see
it
it
could
perfect
it could be evidence
symphony.
of degeneration. It could be evidence of. It sounds like there is some evidence that it's not, and I'm saying that if it is, you still haven't really given us any direct evidence for ape to human ancestry, because for one, it's going to have to be passed on to everybody, and secondly, if hypothetically this chromosomal fusion did happen, it could have easily happened immediately post-flood for everybody to get it, or prior to the flood, where the people coming off the ark could then pass it on. So either way, it's affirming the consequence, because there could be multiple explanations. Guys, have a fun.
Well, hold on.